What's up, guys? My name is Michael and welcome to my YouTube channel. Today we're going to talk about handling errors and exceptions. So basically the code we've dealt with had no errors before in all of these programs, but the thing is real world programs take error conditions into consideration. So today we're going to learn about what exceptions are, how exceptions are used and what they erase, how to build exception hierarchies, and how exceptions fit into an overall error handling approach and what a debugger is. So in real world programs there are a lot of errors, and the bigger the program, the more likely there will be bugs. And in fact, in large programs, it is often the case that many bugs will actually get out of the door and into the final released software. This is true because that is what happens today. So, single biggest problem is really buggy code. And one of the biggest expenses in many programs is that you have to test and fix it. And the person who solves all the problems of producing a good solid code at the lowest cost and the on time will revolutionize the software industry. So the number of discrete kinds of errors that can happen in a program is poor logic. It just doesn't. You thought it works properly, it doesn't. Second is syntactic. You have the wrong function or structure. It's like two of the most common ones. These are like the most common ones. And for research and real world experience, they show that in the development process, you find a logic problem, the more it takes to fix it. And that's the problem. Errors that get compiled in the program at runtime are actually least expensive to fix and are only happen to crash once. So a more common problem is that the logic or the syntactic bug is fragility. Your program works fine, but if the user enters another thing, like a negative number when they're asking for a positive one, it crashes. Another thing, what if the program runs out of memory? Then the floppy disk is left out of the drive, or if an internet connection is lost. So to combat this kind of fragility, programs strive to make their programs bulletproof. So a bulletproof one is one that could handle anything that comes at runtime, from bizarre user input to coming things out of the ordinary from memory. So it's important to distinguish bugs which arise when programmers make a mistake. So logic errors are pretty hard to solve because they required the programmer to find the misunderstood problem and all the other things that happen. Exceptions arise because of unusual and unpredictable problems, such as running out of resources or memory space. So exceptional circumstances. So you can't really eliminate exceptional circumstances, but you can prepare for them. So what happens if your program runs out of memory or allocates an object and there isn't available? How will your program respond? What happens if you divide by 0? Well, you could crash. You could inform the user and exit gracefully. You could inform the user and allow the user to recover and continue. Or you could take corrective action and continue without disturbing the user. Some of these are extremely simple and ready to crash. So here illustrates a problem where many programmers find extremely serious. Here's when you divide by 0. It just doesn't work. Okay. In lines here, here the programmer enters in a value and they not enter the value. The programmer tries to do 90 divided by 0, and it has problems. Division by 0 causes exception problem to error to occur, and the program ends, and most likely an exception is displayed by the operating system. Although it is not always necessary to automatically and silently recover from exceptional circumstances, it is clear that you must do better than this program. So you can't simplify and let your program crash. C++ exception handling provides a type-safe, integrated method for coping with predictable but unusual conditions that arise when running a program. So here's the idea behind exceptions. The basic idea behind exceptions is very straightforward. Computer tries to run a piece of code. The code might done something, lock a file, whatever it is. Logic is included to be prepared in case the code you are trying to execute fails. So for example, you would want to include a code to catch any issues, such as memory not being allocated, a file being unable to be locked, or any other issues. In case your code is being used by other code, for example, one function is calling another, you also need a mechanism to pass information about any problems from your level up to the next. There should be a path from the code where an issue occurs to the code that can handle the error condition. If intervening the layers of functions exist, they should be given an opportunity to clean the issue, but should not be required to include code whose only purpose is to pass along the error condition. So exceptions handling makes all these things come together, and they do it in a reliably straightforward manner. So here's part of an exception. To handle exception, you first must identify what particular piece of code you want to be watched for any exceptions, and this is like accomplished using a try-catch block. So you could do this by having a try-catch block. So put a try and then put braces, then some inside those braces put some dangerous function that you're trying to do that could probably cause an error to happen. In this case, when the some dangerous function executes, if any exception occurs, like anything problems that occurs, it is noted and caught. Adding the keyword try in the braces, all that is required to have your program start watching for exceptions. Of course, if an exception occurs, then you need to act upon it. When the code within a try block is executed, if an exception occurs, the exception said to be thrown. Thrown exceptions can then be caught as shown previously. You can catch an exception with a catch block, and when the exception is thrown, the condition transfers to this catch block, and then the code it goes to the try block, right? And then it catches with the catch block. So when exception is thrown, the control transfers to the appropriate catch block following the current try block. So in the previous example, the ellipse refers to any exception, but when you catch specific types of exceptions, to do this, you need more than one catch block following your code. So like if you want, let's say this dangerous function runs out of memory, right? You try this function. If it runs out of memory, you catch it, right? You catch the exception. That means this you catch that it runs out of memory, right? Then you take some action. You do something. You inform the user. You tell them whatever ran out of memory. If this dangerous function also just so happens to take a file that wasn't found on whatever server, on your computer, whatever, file wasn't found, then you do whatever you want, okay? You catch that exception and you do whatever action it does for a file not found, okay? And then catch is like this is just demonstrating like what exceptions you're supposed to put in here. So yeah, here if an exception is thrown, it is sent to the first catch block following immediately the try block. If the catch block has a type parameter like those in the previous example, the exception is checked to see if it matches the indicated type. If not, the catch statement is checked, and so on, until either a match is found or something other than a catch block is found. When the first match is found, the catch block is executed. Unless you really intended to let other types of exceptions through, it is always a good idea to have the last catch use the ellipse parameter. So if there's a certain type that you want to have, it just keeps try to find it. So like if this some dangerous function, right, just so happens to run out of memory, then it tries to find it in these catch blocks, and it keeps going. And then if there's none found, well, too bad. This function just crashes or something. It's not good though. So basic steps in handling exceptions are identify those areas of programs in which you begin an operation that might raise an exception, put in TryCatch, and then create catch blocks to catch the exceptions if they are thrown. You can either create a catch for a specific type of exception or all exceptions. So yeah. So here, they fix this by putting the values that he's trying to divide by 0, right? He's trying to do 90 divided by 0. So he puts all that code into this try block, and he's going to catch something. So this is going to help you determine what you're going to catch. So on line 20, it contains 3 dots or an ellipsis, my bad. As mentioned previously, this is a special case for catch. So here, this is a special case for catch, all right? It indicates that all exceptions that occur in the preceding TryCatch code should be handled by this catch statement. Unless a prior catch handled the exception in this listing, that will most likely only be a division by 0 error. So as you can see later, it is often better to look for more specific types of exceptions so that you can customize the handling of each. So the try code should be handled by this catch statement. Okay, so unless a prior catch block handled the exception, basically the 3 dots or ellipse is a special case for catch, right? It indicates that all exceptions that occur preceding the try block should be handled by this catch statement. Okay, so here it basically says all exceptions before this try catch should be handled. Okay, before this try should be handled that are not should be handled by this catch statement. Okay, so all the exceptions should be handled before this catch statement. That's what it means. Okay, unless a prior catch block handled the exception. Okay, then it would most likely be a division by 0 error. So you would see later that it is often better to look specific types of exceptions so that you could customize the handling of each. So this is basically saying all exceptions that occur before this try code should be handled by this catch statement. Before this try code. So if there's any error before, any exception, it should be handled before this try catch statement. That's what this catch ... means. So that means, so as you can see, it's actually better to not do it like this way because of it's actually, you should actually handle specific type of catch statements, because this is too generic, you know. So yeah, this must be likely a division by 0 error. As you can see later, it's better to look for more specific types of exceptions. You should also notice that this listing does not catch when it is run. In addition, you can see from the output that the program continued to line 25 rather than the catch statement. So this is confirmed by the fact that the done was exprinted to the console. The listing did not, so here it did not crash when it is run. Like when they took the action here, once it tried to divide by 0, it, after this code, right, once it tried to divide by 0, it realizes that it divided by 0 right over here, right? Then it caught the problem in this catch block. Then it printed out something has gone wrong. After that, it printed out done. That's what they mean here. Okay. So try blocks. Yeah, you should put try followed by abrasive functions. Yeah, pretty much it. You could also cause your own exceptions. This means that you're basically marking the code to be watched and specify how that exception is to be handled. So, however only predefined exceptions were handled, the third part of the exception handling is the ability for you to create your own types of exceptions to be handled. By creating your own exceptions, you gain the ability to have customized handlers catch blocks for exceptions that are meaningful to your application. To create an exception that causes the try statement to react, the keyword throw is used. In essence, you throw the exception, and hopefully a handler catches it, and that's basically what it is. When you throw your own exception, you're basically saying, okay, guys, something bad might occur in this code. Someone else that is using this code, I'm going to notify you guys that something bad is going to happen in this code, okay? And then you're the one that has to, like, handle this problem that might happen. It might not happen, but it might not, but it could happen. It is a possibility. That's what exceptions are used. So you could also create your own exceptions that basically says, okay, this is a problem that might occur within my code, but you have to be able to handle it, okay? So with this statement, exception is thrown. This causes control to be passed to the handler. If the handler can't be found, the program terminates. So if the person who's handling this exception say, okay, I'm not handling this exception, like the handler can't be found, right? Then the program exits. The program just crashes. It terminates. So the value you throw in the exception can be virtually any type. As mentioned earlier, you can set up the corresponding handlers for each different type of object your program might throw. So you can modify this. Okay, so here, wow, okay. So they try to divide by 0, and then it catches a const char pointer. That's what it tries to catch. A const char pointer. And then it prints out, tries to catch a const char pointer. So value that you throw in the exception can be virtually any type. As mentioned earlier, you could set up corresponding handlers for anything. This illustrates when modifying it. So here, okay, let me see. Where's line 24? So on line 24, the catch statement starts a handler. This handler is looking for a constant char pointer. So with exception, strings are matched to a constant char pointer. So the handler starting at 24 catches the throw in line 18. So here, if you divide by 0, right, then they throw division by 0. They throw this exception. Okay, this is going to say they throw this exception, division by 0. Okay, that means that this is a message is put out in the air, division by 0. This one catches it. It catches this message. It's a char pointer. So that's basically a string. Remember, strings are just character arrays, and a character array can also be represented as a pointer in C++. So this is basically catching this string that was thrown, division by 0. And after that, it basically printed a new line and then 3 stars, and then, yeah, division by 0, it printed out 3 lines, and let me see. Yeah, through division by 0, and then printed out 3 stars, a new line, and then EX, which is the string, division by 0, and then 3 more stars, and that's what these are. Then after that, this was over, it printed out done. So that's basically what happened. If your exception has been a more serious problem, you could have exited the application after printing the message on line 26. If you throw your exception in a function that was called by another function, you could have passed the exception up. To pass on an exception, you can simply call the throw command without any parameter. This causes the existing exception to be rethrown from the current location. Okay, so you can also create an exception class. You can create much more complex classes for throwing an exception. So here they stripped down array class from the templates. Okay, so let's see, how do they create their own exceptions? Okay, all these were just the operators I use override. Okay. So you create an array, size 20. I'm guessing this is the size. Yeah, it's the size. Okay, so create an array of size 20. You loop through all of it, 1 to 100, 0 to 100, and then set all the values to 0 to 99 because they go up to 100. If something happens that goes wrong, they catches it and they say unable to process your input, and then they say done. They catch the array X boundary. How did they do that? Okay, so where's line 99? So here is a stripped down class. On line 24, a new class X boundary is declared within the declaration of the outer class array. So on line 24, they created a new class called X boundary, and it defines an exception class. And this is inside their array class. Okay? And then where did they say? This new class is not in any distinguished as an exception class. It's just a class the same as any other. This particular class is incredibly simple. It has no data and no methods. Nevertheless, it is a valid class in every way. So in fact, it is incorrect to say it has no methods because the compiler automatically creates a default constructor, a copy constructor, an assignment constructor. So it actually has 4 class methods but no data. Okay, so note that declaring from the array serves only 2 purposes. 2 classes together on hand. The array has no special access to X boundary. X boundary has peripheral access to members of array. Okay, so on lines 63 to 70 and 72 to 79, the offset operators are modified to examine the offset request. So I think it was 62 to 70. Okay, so here they changed if there's a problem with the offset. In this case, it's index. Offset is just the index. So remember, the array is indexed by like 0 to the length minus 1 to the size minus 1, right? If there's a problem with the index, they throw this, okay? If it's like negative or greater than the size, they throw X boundary. which is they're throwing a new class, X boundary, which is an exception. And they created X boundary in their declaration of their class. It's just an empty class called X boundary. So then whenever a problem occurs with the operator, where it's something bad happens with the index, like you can't access a value, like you can't access a negative index in array in C++. So then if that happens, they throw this exception. If it's greater, if it's also greater than the size, they also throw this exception that X boundary, it's gone off the boundary, so you can't do that. They also have another one. This is just another helper function. They overloaded it twice for some reason. This is if the array is constant, I guess. And they do the same thing. They throw an exception. So, if it is out of range, they throw the X bounded class as an exception. The parentheses are required to distinguish what is called between this call to the X bounded constructor and the use of enumerated constant. So on line 90, the main part of the program is by declaring an array object that can hold 20 values. Then they try to TryCatch block on line 98, and within that TryCatch block, 101 integers are added to the array declared on line 90. So then the handler was able to catch the X boundary exceptions right here. So here they made an array of size 20, and they loop through it from 0 to 100, and they try to add 99 values to it, right? Up to 99. 0 to up to 99. And that definitely causes an exception to throw, because it's beyond the scope of this. It's beyond the index is beyond like the capability of this array. Like because a 99 is like way, even 21 is greater than 20. The size is greater than. That's why I threw this exception. So they threw the exception, and then they were able to catch it in this block, and then they print out unable to process your input. See, after 20, unable to process your input. So yeah, that's what they did. Pretty much, yeah. Yeah, okay. So placing TryCatch block. Figure out where to place your TryCatch block can be really hard. It's not really obvious, but which actions can raise an exception. The next question is where to catch the exception. It might be that you'll want to throw all your memory exceptions where the memory is allocated, but you'll want to catch the exceptions high in the program where you deal with the user interface. So when trying to determine try block locations, look to where you allocate memory or use resources. Other things to look for are out-of-bound errors, illegal input, and so forth. So at the very least, put a TryCatch block around all the code in main. TryCatch usually belongs to in high-level functions, particularly those that know about the program's user interface. For instance, a utility class should not generally catch exceptions that need to be reported to the user because it might be used in windowed programs or console programs, or even in programs that communicate with users via the web. So how catching exceptions work. Here's how it works. When an exception is thrown, the call stack is examined. Call stack is listed as a function, the list of function calls that the program person called, right? So the call stack is just like all the list of functions that the program called, right? And then when one part of the program invokes another function. So the call stack tracks the execution path. If main calls the function get favor food calls the function lookup preferences, which in turn calls the fstream operator greater. All these are put on the call stack. Then the recursive function might be put on the call stack many times. The exception is passed up the call stack to the enclosing block. This is called unwinding the stack. When the stack is unwound, the destructors for local objects on the stack are invoked and the objects are destroyed. One or many more catch statements follow each try block. If the exception matches one of the catch statements, it is considered to be handled by having that statement execute. If it doesn't match anything, the unwinding of the stack continues. Okay, so if the exception reaches all the way to the beginning of the main and is still not caught, a built-in handler is called that terminates the program. So that's basically how it works. You could use more than one catch specification. Here, they do that here. Where did they do that? Oh, okay. Wow, okay. So they create an array of size 0. Try loop through 100. It's gonna go to X boundary. Yeah, you could put as many catch statements. Look at that. Let's see. What was the point of it? It is impossible for more than one condition to cause an exception. In this case, the catch statements can be lined one after another, more like conditions and switch statements. This is equivalent to the default statement is catch everything. Statement indicated by catch ... So catch ... is catching everything. The catch everything statement. That's what it means. Okay, so that's what they did here. Catch ... means catch everything. Okay, exception hierarchies. Exceptions are classes as such they can derive from hierarchies. It might be dangerous. It might be advantageous to create a class x size and to derive it from x0, x too small, x too big. Thus, some functions might just catch x size errors, and other functions might just catch the specific type of x size error. So here they illustrate the idea. Yeah, they have. Where's the? Oh, okay, so they have multiple classes for x size, and here they're just inheriting whatever the previous exception. Like too big, they're just inheriting x size, and too small, they're just inheriting x size. So that means that basically these exceptions, they can be handled just like classes, like hierarchies. So yeah, here they handled all of them. Significance is that where the class hierarchy is established, classes x too big are derived from x size and x0 are derived from x too small. The array is created with size 0, but what is this? If a wrong exception appears to be caught, examine the catch carefully. However, you will find that it looks for an exception of type x too small before it looks for an exception of type x0. Because x0 is thrown and x0 object is an x too small object, it is caught by the handler for x too small. After being handled, the exception is not passed on to the other handler, so the handler of x0 is never called. The solution of this problem is examine carefully order the handler so that the most specific handler comes first and the least specific handler comes later. In this problem, switching the placement of two handlers, x0, x too small fixes the problem. Alright, the problem here is that because of okay. They're trying to throw x too small, right? But because x0 is a okay. Okay, so it looks for the exception of x too small before it looks for an exception of x0. Because x0 is thrown and x0 is an x too small, it is caught by the handler for too small. So what's happened is that x0 is an exception that they made, right? But they derived x0 from x too small. Because x0 is also an x too small, this statement gets caught first. Okay? So that's why it never went to x0. So to fix this, you could just make this more specific, the most specific first and then the least specific. So you could swap where x0 goes. Yeah, so yeah. Data and exceptions and naming exception objects. Often you will want to know more than just one type of exception was thrown, so you can respond properly to the error. Exception classes are the same as any other class. You are free to provide data and initialize that data in a constructor and read that data any listing. So here they do that. Where do they do that? Oh yeah, okay. So here they created the class x size, which is an exception, and yeah, you could pass in data to the constructor. X int size and get size. Okay, so that's what they did, and then yeah, they just passed it in. So they do that, and yeah, it's just you could pass in data to your thing, and then it would into your exception, and it would basically just handle it. The difference is here they pass in the exception 117. Okay, so declaration is to include a member variable its size on line 33 and get size on line 31. In addition, a constructor has been added that takes an integer and initializes the member variable as shown in line 29. Derived classes declare a constructor that does nothing but initialize the base class. No other functions were declared, in part to save space in the listing. The catch statements on line 113 and 135 are modified to name the exception they catch the exception and to use this object to access the data stored in the size. Okay, so because they took for the X size, right? X size is they create a class of X size, and it passes in, has an instance variable its size, and they pass it in and they initialize it. Well, to access that, first to throw it, they throw x0 and they pass in the size of it, because x0 is a class that has instance variable of size, so they have to pass into the constructor. And after they do that for all these things, because all these were inherited from from x0, right? So then to catch the exception, they needed an object called the exception. They put it after array : x0 in order to access this is an x0 object, right? It was instantiated. It's not instantiated. It's a x0 object. So in order to catch it, they have an x0 object. They catch the array x0 and the exception, which is x0 object, and then to access the values, the instance variable of size, they print out the exception dot get size. So yeah, that's how you catch objects exceptions that have instance variables in them. You need an object to catch it. Okay, so you also could pass by reference and use virtual functions and exceptions. Okay, so yeah, you could do that same thing with basically anything. Here they made these virtual functions. They made the size. Yeah. Yeah. Pretty much, yeah. Okay, so print error prints a message, and the actual size of the class is overwritten in the derived classes. Because the exception object is declared to be a reference, when print error is called with a reference to the object, polymorphism causes the right print error to be invoked. The clone is cleaner and easier to understand. So in line 141, because they use a reference, it calls the right exception to be printed. Because everything was inherited from x0, and because here they're doing out of bounds, right? They're trying to go out of the beyond the size. They're trying to go beyond the size, right? So here, if it's beyond the size, where's the class, the size? Okay, x size, yeah. So x size is negative. Okay, so this is negative, too small. X too small inherits x size. Okay, the input is too small, too big. Okay, so because they passed it by exception, the right one is printed out. Too small, receive 9. The right print error is printed out. Because what's happening is that they create an array of size 9, and they're trying to go to the beyond that array, okay? And then it throws an exception, right? And it should throw too small exception. And that's an exception object, right? And because they used the reference, it is now able, when you print the error, it actually prints out the too small error printed out, because it calls the right one because of polymorphism. Okay, exceptions and templates. When creating exceptions to work with templates, you have a choice. You can create an exception for each instance of the template, or you can use exception classes declared outside the template declaration. So here okay. So you could create templates for your exceptions. Okay. Yeah, they do that here. Basically everywhere here. Where's your class that they did? No, this is just the array. Yeah. Do here. Pretty much. Can have exceptions without errors. Virtual. When C++ got together for a virtual beer in the cyberspace after work, talked to others when exception could use for routine. Some maintain that by that nature, exception should be reversed for those predictable but exceptional circumstances that a programmer must anticipate and that are not part of the routine processing of the code. Others pointed out that exceptions offer a powerful and clean way to return through many layers of function calls without damaging the risk of memory leaks. A frequent example is this: the user requests an action in a GUI interface environment. The part of the code that catches the request must call a member function on a dialog manager, which in turn calls a code that processes the request, which calls code that decides which dialog box to use, which in turn calls code to pull up a dialog box. Okay, so yeah, you could use exceptions for that. Word about code rot. Code rot is a phenomenon where software deteriorates due to being neglected. If it's well written, yeah, it's well written. Just make sure you use exceptions. Bugs and debugging. So you could most people have debuggers. I'm actually not gonna show. Well, on Visual Studio you could do that. I'm actually not gonna show that right now because I need to have that. My Visual Studio is having a problem. But you could create breakpoints and you could go line by code. I might show it later, but for now, I'm not. Anyway, rate, comment, subscribe. That was all about exceptions. I'll check you guys later. Peace.